Have you ever imagined a library that doesn't just store books, but actually understands the ideas inside them? A place that could connect dots you never saw, answer incredibly complex questions, and basically learn right alongside you? Well, today, we're going to take a look at a project that's trying to build exactly that, a modern-day Library of Alexandria, but this time powered by AI.
The original Library of Alexandria was this incredible, almost mythical attempt to gather all human knowledge in one place. But its destruction was a brutal lesson for humanity. Knowledge is fragile. It's transient. And believe it or not, in our digital age, we're facing a similar but kind of opposite problem. We have to figure out how to make sense of the absolute mountain of information we're creating every single second.
I mean, think about it. We are drowning in data, but we're often starving for real wisdom. And the rise of AI is just cranking up the volume, creating this massive digital flood. So, the real question, the one we're going to dig into today, is how do we turn that flood into an actual, usable well of knowledge? Okay, so let's break this down. The first thing we need to wrap our heads around is what we can call the modern knowledge problem. Think about your own digital life for a second. It's just a sea of unstructured text, right? Emails, articles you've saved, notes, documents, it's all there. And yeah, it's a treasure trove of information, but it's also a complete mess. Sure, you can search for keywords, but you can't really ask deeper questions like, hey, what's the relationship between this idea in this paper and that concept in my notes from last year? It's just not built for that.
So, how do we fix this? How do we bring some order to all that chaos? Well, a project called Hypatia has this really elegant, powerful idea. What if we could structure knowledge in the same way our own brains do?
And the way Hypatia does this is with something called a knowledge graph. Honestly, the best way to think about it is like a digital brain. See, our minds don't just store random, disconnected facts. We understand the relationships between things. A knowledge graph does the exact same thing for a computer. It represents concepts as these little points of light called nodes, and then draws lines or edges between them to show how they're all connected. So how do you actually build one of these things in Hypatia? It's actually a super simple two-step process. First, you create a node, which is just a single concept, let's say the programming language Rust. Then you create an edge to connect it to another node. This forms a basic statement, a little sentence, a subject, a verb, and an object. Like, Rust is a systems language. And with just those two simple building blocks, you can start to map out this incredibly rich, interconnected web of knowledge. All right, so we've got our graph, our digital brain. But how do we talk to it? How do we ask it questions? For that, you need a special kind of language. And in this case, that language is called JSE.
So JSE stands for JSON Structural Expression. And here's the best analogy for it. If you think of regular old JSON as a noun, it's great for just describing a static thing. Then JSE is a complete sentence with a verb. It doesn't just describe data. It lets you express actions, logic, and intent. It's literally the language you use to have a real conversation with your knowledge graph.
So how does it work? Well, it all comes down to these things called operators, special commands that start with a $sign. You've got your basics, of course, like .eq for finding an exact match, or .search for just regular text search. But the real magic, the secret sauce, is in operators like .tribble. This one lets you specifically search for those subject-predicate-object patterns, the actual relationships you've built into your graph. Let's look at a quick example. This query here is basically asking Hypatia, hey, show me every single statement where Rust is the subject of the sentence. Those little asterisks are just wildcards, meaning we don't care what the predicate or the object is. See what's happening? We're not just searching for the word Rust, we're asking a structural question about its role in our entire web of knowledge. And that is the power of JS.
Now, this all sounds really cool and precise, but it brings up a huge question. In the world of AI right now, the absolute gold standard for this kind of thing is vector search. So, how does this graph-based approach actually stack up?
Yeah, for anyone working in AI, vector search is pretty much the default tool. It's a really powerful technique that finds things that are similar in meaning by turning text into these complex numerical fingerprints. And it works. It's super effective, but it's not perfect. It definitely has its own set of limitations.
So let's look at the numbers. How does Hypatia actually compare? The results from this benchmark are, well, they're pretty jaw-dropping. Hypatia hit perfect recall, which means it found every single thing it was supposed to find. The vector database, while pretty good, still missed some. And then look at the speed difference. We're talking microseconds for Hypatia versus milliseconds for the vector database. Just to put that into perspective, that's not a small difference. We're talking about a performance gap of anywhere from 10 to 100 times faster. That's a huge deal.
So what's the big takeaway from all this? Well, this benchmark suggests that Hypatia's graph-based method is a seriously compelling alternative. You get higher accuracy, you get way lower latency, and, this is a big one, you don't have to rely on any external models, so your results are totally deterministic and predictable, every single time.
Okay, so let's bring this all home. What does a super fast, super accurate, and totally structured knowledge system really mean for the future of AI? Well, it opens the door for AI to become our own personal, tireless librarian.
And this is where it all clicks into place. We already know that large language models are fantastic at generating structured data, like JSON. JXZ just takes that one step further. By teaching an AI to speak JXZ, we're giving it the power to not just spit out information, but to actually organize it, structure it, and automatically build its own knowledge base from everything it learns.
So I'll leave you with this thought. What if your AI could do more than just answer your questions? What if it could help you build your own personal Library of Alexandria? A library that's always growing, always learning, and always making new connections, all on your behalf. A library that isn't just a dusty old collection of facts, but a true partner in your search for knowledge. That's the future that projects like Hypatia are trying to build.